Alright, so in this question, we're asked to compare momentums in two different objects when the mass in one object is larger than the other. Now, since mass is a part of the momentum formula, P equals mv, it might seem obvious to assume that, well, if the mass in one's larger, then that must have the larger momentum. But since they have the same kinetic energy, and since velocity is also part of the kinetic energy, if they have the same kinetic energy, that would seem to imply that the velocity in one might be lower. So it's difficult to tell right off the bat, like that, which one would actually have the greater momentum. So instead of trying to guess about it, instead let's prove it mathematically. And we can do this by taking the momentum formula and writing this in terms of kinetic energy. So how exactly are we going to work this formula right here, the kinetic energy formula, into this? And that's what makes this question kind of tricky, because it requires quite a bit of thinking to get this into this. So let's start with velocity. So here we have velocity squared, and right here we have a velocity without a square. So let's write it with a velocity squared without actually changing the value, so that it's still equal to momentum. So what I'll do here is I'll write mv with the square over it, but in order to make it not lose its equal value, I'm also going to square the mass and then put a square root over it. So now it's still equal to that, but now we're one step closer to having this in terms of that. Now you'll notice that that mass is also part of the KE formula, but it's not squared. So how are we going to fix that exactly? So what we can do is expand this part of the formula by taking one of the masses out, because fortunately this is all in one term. So we can take one mass out and have it just in terms of mass times the mv squared, all in one parenthetical statement here. Great. So now the only thing left that's missing is the half. So once again, keeping that equal to this, I'm going to keep the square root again. And so we want all of this to be half of what it is now. But in order to, again, keep it equal, we're going to have to double the outside by 2. So I'm going to write this as 2m times 1/2 mv squared. Great. So now we've got 1/2 mv squared in that, which means that this is now equal to the square root of 2m times kinetic energy. So now it's especially, now that we know that momentum is also equal to this, it's now much easier to see that if the mass is going to be bigger, that as long as the kinetic energy is constant, and the 2 is obviously not going to change since it's part of the formula, if the mass is going to increase, then now we can see that that most certainly will increase the momentum.